Section 1.6, Absolute Value Equations and Inequalities. So absolute value, written in this case as you have your absolute value bars with your variable inside, is the distance from zero on a number line. So if you remember back in school, a lot of time, or back in middle school or even younger, depending on when you learned absolute value, the absolute value of 4 is 4 because it's 4 units away from 0. The absolute value of negative 4 is also 4 because it's 4 units away from 0. Here we're looking to solve the absolute value equations. So in example A, we've got the absolute value of 2x minus 1 equals 5. So we're going to recognize that this has two opportunities. So before we solve this, what we have to do is isolate the absolute value and then break it down in its two different opportunities. One opportunity being it's 2x minus 1 equals a positive 5. The other being we have 2x minus 1 equals negative 5. Now we're just going to solve these two equations. We can do so quickly. We would add the 1 to both sides. So you have 2x equals 6 here. Here you're going to get 2x equals negative 4. On the left, we'll divide by 2. X equals 3. On the right, we'll divide by 2. X equals negative 2. So for this absolute value equation, we have two answers, 3 and negative 2. So then we'll just graph this on a number line. So negative 2, put 3 here, put 0 there. So our solutions take place here and here. For question B, we're doing the same thing. We're going to account for both possibilities. We've got 3x plus 2 equals 4. And we also have 3x plus 2 equals negative 4. I'm going to move this. I don't like where I placed that. So we're going to put it here. 3x plus 2 equals negative 4. So we're going to solve both of these. Just normal equations. Solve them as you would. You're going to subtract 2. So we've got 3x equals 2. Subtract 2. 3x equals negative 6. Divide by 3. X equals 2/3. Here we're going to divide by 3. X equals negative 2. So we've solved these. And now we just have to graph our solution. So negative 2, 0, and 2/3. And so we have a solution here and here. We're going to continue to solve. We can graph our solutions. The graphing part's easy, so I'm probably not going to do it in the video right now. But for right now, we're going to go ahead and solve these. Remember when I said in the first part of this, we have to isolate our absolute value, meaning before we separate into our two quantities, we first have to get the absolute value bars and everything inside them alone. So for this first problem here, for C, I'm going to subtract 3 to start with. Because I'm trying to get the absolute value stuff all by itself. This is what I want to be all alone. So I subtract 3, I've got 2, absolute value of x plus 9 equals 4. I'll divide by 2. Then I've got the absolute value of x plus 9 equals 2. Now I'm going to separate this into my two quantities. So x plus 9 equals 2. X plus 9 equals negative 2. Now I'm going to go ahead and solve. So I'm going to subtract 9 from this side. So x equals negative 7. Here I'll subtract 9 as well. X equals negative 11. These are my two solutions. Once again, I could put my number line down there and plot my points, but to save time, I'm going to go ahead and jump to example D. So just like the previous example, we want to get this part all alone. So to start with, I'm going to move the 1 by adding it to the other side. So 3, absolute value of x plus 2 equals 9. Divide by 3. We'll have the absolute value of x plus 2 equals 3. Now I can separate. So x plus 2 equals 3, x plus 2 equals negative 3. Now I just want to solve. So I subtract 2, x equals 1, subtract 2, x equals negative 5. Now we need to talk about extraneous solutions. A solution derived from an original equation that is not a solution of the original equation. So when you've got the solution and you plug it back in, it ends up not working. That's an extraneous solution. So now we're going to check for extraneous solutions using this absolute value equation. So we're going to go ahead and solve this. So right now we already have our absolute value equation isolated, so we have to create the two circumstances here that take place. First one being 3x plus 2 equals just the normal 4x plus 5. The other one, on the other hand, is going to be 3x plus 2 equals the negative version of the 4x plus 5. So I'm just going to put the negative outside the parentheses, and I will have to distribute here when I get to that point. So let's just go ahead and solve the left equation first. So I'm going to move the 3x, I'll subtract it to the other side. So I've got 2 equals x plus 5. I'll subtract the 5. I've got negative 3 equals x. So there's one solution. Then on the other side, I'm going to solve this. So first thing I have to do is distribute the negative. So negative 4x minus 5 equals 3x plus 2. I'll go ahead and, in this case, I'm going to add the 4x to the other side. So I've got 7x plus 2 equals negative 5. I'll subtract 2. So 7x equals negative 7. So clearly x is going to equal negative 1 in this case. So now here's the part where we figure out if we have an extraneous solution. We're going to plug this back in and test. So let's go ahead and test and see what we have. We'll do the test in orange. So we'll start with the negative 3 first. So we've got the absolute value of 3 times negative 3 plus 2 equals 4 times negative 3 plus 5. So here, negative 3 times 3 is negative 9, plus 2 is negative 7. The absolute value of negative 7 is 7. Here we've got 4 times negative 3 is negative 12, plus 5 is negative 7. So now we have 7 equals negative 7. That's not true. So that's going to make the negative 3 our extraneous solution here, at least one. We still have to test the other one. So now we're going to test the negative 1. So doing the exact same thing, we've got 3 times negative 1 plus 2, oh, wrong symbol, equals 4 times negative 1 plus 5. So here, 3 times negative 1 is negative 3, plus 2 is negative 1. Absolute value of negative 1 is just 1. 4 times negative 1 is negative 4, plus 5 is 1. In this case, 1 equals 1, so 1 is a good solution. So our only extraneous solution is negative 3. Now we're going to talk about solving absolute value inequalities. Very similar to what we just did with the equations, just a few minor variances. So once again, notice the absolute value is isolated, so we have to create our two circumstances. First one being 2x minus 1 is less than 5. The other one is where the variance happens. It becomes 2x minus 1 is greater than negative 5. Notice here that I changed the symbol on the 5 from positive to negative, but I also flipped my inequality. So in this case, we're just going to solve both of these. So for the left inequality, we're going to add 1. So we've got 2x is less than 6. Divide by 2. X is less than 3. Same thing for the one on the right. We'll add 1. So 2x is greater than negative 4. Divide by 2. X is greater than negative 2. Because this is an inequality, we're going to go ahead and graph. So negative 2, 0, 3. At both cases, we have open circles. For the 3, we are less than 3, so we're going this way. For the negative 2, we are greater than, so we're going to the right. And so in this case, we're bounded between. So the inequalities here is your x has to be greater than negative 2, but less than 3. Question B, same idea. We're going to go ahead and separate this. We've got 2x plus 4 less than or equal to 6. So 2x plus 4 is less than or equal to 6. And then we account for the other one. So 2x plus 4, in this case, greater than or equal to 6, is now less than or equal to negative 6. So we have our two inequalities. We have 2x plus 4 is greater than or equal to 6, and 2x plus 4 is less than or equal to negative 6. At this point, we're going to go ahead and solve these. So minus 4, so that gives us 2x is greater than or equal to 2. Divide by 2, x is greater than or equal to 1. Here we're going to do the same thing, subtract 4, so 2x less than or equal to negative 10. Divide by 2, x is less than or equal to negative 5. And so at this point, we're going to go ahead and graph these. So with this, we've got at negative 5, we're going to have a closed circle going to the left. Here at 1, we're going to have an open circle going to the right. Example C and D, very similar. We're going to go ahead and separate and solve. So 3x minus 4 absolute value is less than or equal to 8. So we're going to have 3x minus 4 less than or equal to 8. Then we've got 3x minus 4 is greater than or equal to negative 8. We want to solve both of these, so we'll add 4. 3x is less than or equal to 12. Divided by 3. X is less than or equal to 4. So there's 1. Here, 3x minus 4 is greater than or equal to negative 8. We'll add 4. So 3x is greater than or equal to negative 4. Divide by 3. X is greater than or equal to negative 4/3. So notice that in the last problem we saw like this where it was less than, we saw that they came together. When the absolute value started as less than, we saw that the two graphs came together. Let's see what happens here. So we've got negative 4/3, put 0 here, we'll put 4 way over here. So at negative 4/3, we have a closed circle, and we're going to the right. At 4, we have a closed circle, and we're going to the left. So just like the other less than example, notice that they came together, kind of like the and situations do with our compound inequalities. They're coming together. For example D, we have a greater than symbol. So let's see if this follows the similar trend as the previous example that we saw in the last part of the video. So we'll go ahead and separate. 5x plus 10 is greater than 15. 5x plus 10 is less than negative 15. So in this case, we're going to go ahead and solve. Subtract 10, so 5x greater than 5, divide by 5, x is greater than 1. Here we'll subtract 10, so 5x less than negative 25, divide by 5, x is less than negative 5. So previously when we had the greater than, when we started the absolute value inequalities like this, we saw the two graphs diverge. So let's see what happens here. So we've got negative 5, 0, 1. So at negative 5, we've got an open circle going to the left. At 1, we've got an open circle going to the right. And here is just a quick concept summary from your book. If you go to the book, you'll see this more clearly, just a photo of it. But just some things to keep in mind when you're dealing with absolute value.